Hello, Year 3s, and welcome to your flipped classroom video for this week for science. In this video, we are going to be going over our knowledge organizers for our topic. So I'm just going to share my screen with you. So, as you already know from what we've done, our topic this term is forces and magnets. And we've spent the last two lessons looking at what forces are, and we've also looked at gravity as a force. So we have looked a little bit at that. So I'm going to go through the knowledge organizer with you, and then I'm going to give you a task at the end that I would like you to try and do. We're going to start off with our vocabulary on the side here. So the words that we're going to go through are as follows. Force. Force. Now, force is the scientific word for the pulling and pushing effect that we spoke about earlier this week. Friction. Friction. Friction is the force that makes it difficult for things to move when they touch each other. Magnet. Magnet. And a magnet is a piece of iron or other materials which attract some metals towards itself. Now, I have two magnets here, and you can see that when we do this, and I'm not pushing them, they pull towards each other and they are attached. So these are magnets, and you do get magnets in different forms. I have a U-shaped magnet here, and I've also got a horseshoe magnet. So you do get them in different shapes, and there is a picture down below that we'll have a look at that then shows you a little bit, a few more magnets that we do get. Next word is magnetic. Magnetic. Now, magnetic means that something that acts like a magnet. If it is magnetic, it acts like a magnet, and it attracts some metals towards itself. Next word is poles. Poles. Now, a magnet has a north and a south pole at each end of it. So we've got the blue here is, if you have a look, it's got very gently, you can see there's an S there. And then if we turn this over on the other side, there is an N, and that is our north pole and the south pole of our magnets. Now, the next word is attract. Attract. If something attracts to something else, the force of one object pulls another one towards itself, and it is attracted. It attracts to the other object. If it repels, the force of one object pushes another object away. So like these ones, if I try and push them together, I really struggle to push them together. They keep moving away from each other. So they are repelling each other. If we look at the magnets themselves, if we look at the second part of our text map, magnets are objects or materials that produce a magnetic field and attract or repel magnetic objects. Magnets have two poles, just like we've been through. It's a north pole and a south pole. And if you put them together, there are a variety of different ways these poles could act. If we get a south pole and a north pole and we put them, they will attract towards each other. If I have a south pole and another south pole, I can see that it repels away from each other. And if I have a north pole and a south pole, they attract. But if I have a north pole and a north pole, they will also repel against each other. Now, when looking at magnets as well, there are specific things that are magnetic and non-magnetic. Believe it or not all metals are magnetic. So some are and some aren't. Things like iron, nickel, cobalt, steel, and paper clips are all magnetic. But things like rubber, coins, plastic, gold, and silver are not magnetic. They are non-magnetic materials. So, what are forces? A force is simply a push or a pull in a particular direction. Forces result from an object interaction with another object. And gravity, which we learned about on Friday, is the force that pulls things to the ground. Gravity also holds Earth and other planets in their orbit around the sun. Friction is a word that we've also looked at briefly in our vocabulary words here. Friction is a force between two surfaces that are sliding or trying to slide across each other. Friction works in the opposite direction to which the object is moving. It slows down the moving object. If you have something that is on a smooth surface, it will create less friction. For example, a polished wood floor or a smooth table. If you push something across it, it has less friction and the object will move slightly quicker. If you use that same object on a rough surface, like a carpet or a thick carpet, the thick carpet creates more friction. So when you push that same object across the carpet, it will go slower. It will be slowed down because of friction on that rough surface. Earth's magnetism. The Earth, believe it or not, is a giant magnet with a magnetic north pole and a south pole. A compass, if you have one, always points towards the North Pole because of the Earth's magnetic field. And you'll know from work with compasses previously that if you move around, the compass will always point north. The little arrow will always point to where north is. So you'll always be able to know because that's where the point of a compass will always be pointing. Applied force. This is at the bottom here. It refers to the force applied either by a person to an object or by an object to another object. The amount of applied force depends on the weight of the body or the object. So it's the amount of force you are applying to that object. And we have a push and a pull force with the arrows that show what direction the force is moving in. If we look at magnetic force versus physical force, magnetic forces are non-contact forces. They pull or push an object without touching it. So if you have a magnet at home and you run it near, doesn't have to be particularly touching something that is magnetic, it will pick it up. So it is, without touching it, it will move that object. Magnetism, like gravity, is different to most forces because it doesn't need contact with an object to make it move. So an object doesn't have to be on it to be able to make it move. It actually can be quite close to it. And I will show you with this. If I'm holding this down here, you can see I'm pulling, it pulls, and it actually pulls this up. Okay, so it's attracting it, and I can do that with magnetic objects. It will pull those objects and move those objects without even having to touch it. Lastly, we can have different types of magnets. Now, magnets come in lots of different shapes and sizes. Some magnets can be stronger than others and can create bigger pushing or pulling forces. So this, for example, is a U-shaped magnet. Horseshoe magnet that looks something like that. We have bar magnets that look a little bit like that. And then we have ring magnets as well that you'll see in that picture that are looking like a ring and they're shaped like a magnet. So my task to you today is as follows. Can you show me an object or move an object across a smooth surface and then move an object across a rough surface and tell me what the friction does or what the friction causes that object to do? So we've said there'll be less friction on a smooth surface and more friction on a rough surface. So can you test out what I've just said to you by running either a toy car or some kind of rolling object, firstly across a smooth surface, then across a rough surface, and explaining to me what the difference was and what you noticed? Don't forget to share what you have found out with us next week. Bye.